Good morning, everybody. I don't know if you've ever had this experience of using a technology for the first time and being absolutely gripped by it to the point that you want to go home after work and keep working on it and in the evenings, and you notice that you're kind of being really captured, your imagination's being captured by it. For me, back in 2016, that was this idea of functions and serverless. And I started this project in my own time and just had a very simple use case. I wanted to run Alexa skills on my own hardware with Docker instead of in the cloud. It turned out that that was actually a really popular idea, and here we are today, and it's now way bigger than I thought it could ever be. So today, we're going to take a quick look at the 2019 landscape. As Jace said, things are evolving and moving, but there's a lot of convergence as well, and it's not necessarily where we expected it to be originally. We'll also see what the end user community is like for OpenFaaS, some of the highlights. I know that Doug asked how many people are using serverless in production. We have about 40 end user companies that we know that they are, and many more that have signed up on Slack over the last few months that are also going on that journey. We'll also see some of the roadmap for 2019 and what we're planning on doing, but again, that's subject to change because it's driven by what the end users want. And if you do want to tweet, here's the handles. I would really appreciate that. So the landscape that we've all seen is the cloud-native landscape, that huge one with all the little boxes on it, and some people are quite confused by it. There was a new landscape put together by Redpoint in combination with the serverless working group, and it looked a bit like this, but I find this equally confusing because there's a bit of a dichotomy. There's a split down the middle of platforms that are proprietary and hosted, where you can't get any control, there's less portability, and the platforms that are open source, like Knative, OpenFaaS, OpenWhisk, where there's a lot more that you can do with it. Now, I think it's probably time for a new landscape, and I'll tell you a bit more about that in a minute. If you are a serverless 1.0 user, the old landscape, then you probably, as an AWS customer, are going to use Lambda. Why? Because you already are paying them, you've got your billing, your accounting set up. And Lambda comes with its own set of constraints and own set of regions where it's live. I think we looked at this just to double check, and you're still limited to a 50 megabyte zip file for your upload. You're kind of out of luck if you need something more. Your Node.js function has a specific signature. This is something we've touched on in the work group. And then when you're a Google customer, it's a similar experience, but there's completely different constraints, different availability regions, different logging frameworks, and it's very tough to move completely from one stack to another. Now, in the enterprise, we don't just have functions. This is something that I know Knative has helped bring to the forefront, is we've got these microservices too, and lift and shift is actually quite popular. Docker proved that. You can't always completely modernize and rewrite applications. Teams aren't willing to do that. So we need something in the enterprise because we've got these big question marks. We've also had a few pain points around serverless. This is the new stack. They interviewed 250 people, and some of them said portability was a problem. We just touched on that. But what about if you actually really bought into Google Stack or Amazon? You probably don't care, right? But the control element is also very important, and for those people, they just don't have any options. As soon as they hit the limits, what can you do? Right? You're really at the mercy of your vendor. Now, there's a lot of good to be said for serverless 1.0 as well. But then when it comes to a developer experience, when you want to debug this and trace it, it's pretty tough. Even using something like SAM for Amazon, it's not the same environment that you're running in production. It's not the same logging, it's not the same user experience. And this says that there's a bit of a lack of tooling. Well, we know there's a lot out there for AWS because it's got such a big market share, but perhaps if you're a GCP customer and Google Cloud Functions, there's a little less that's available for you. And I think we need to change that. So I want to introduce you to serverless 2.0, and this is something that I've been talking about over the last year. And the idea is that you can run your code anywhere because we're using a Docker image. ThoughtWorks have actually recommended that people don't pursue a multi-cloud strategy. making their own abstractions, but instead rely on Docker images because of the portability. Now that allows us to run any code we want, whether there's a HTTP server or not, any binary for Linux or Windows. And once you have that level of portability, you can pretty much run anything you want. Now we don't have to lose the auto-scaling either. We can actually still have that through various different things like the cluster auto-scaling, bursting out, and even connecting to on-premise hypervisors and requesting additional capacity as needed. So I want to propose a new contract, and actually I think we've already done this as a community, which is a runtime contract. HTTP on port 8080, a Docker image, something that's stateless and immutable. Right? Now that has actually been adopted by OpenFaaS and popularized. And we've also seen that this is fully compatible with the Knative project. Thank you for doing that. And what we're going to see is a demo of building an image on OpenFaaS and deploying it straight to Knative without any modifications. So this is what I want to propose as our new serverless 2.0 landscape. And if you're not on here, I'm sorry about that. But I'm trying to keep this really focused just on projects that run and build Docker images. Now, I know there's more that we could have here. But if we just focus, we've got the build templates. This is where we take source code and produce a Docker image for a CLI. So we're not talking about zip files in S3, real Docker images. OpenFaaS and build packs do this, they're very well known for it. And Azure Functions has open sourced some code that does the same. Once you have that, you need some kind of way of serving that, somewhere to deploy it to. And two well-known projects are OpenFaaS and Knative Serving. They'll take your Docker image, and they'll allow ingress in. They may do some traffic shifting, allow revisions, various other things. Scale from zero is something that some customers are interested in. Believe me, not many of the OpenFaaS users are interested in this. But OpenFaaS does this, Knative, and as of December, Osiris from Azure also does this. So we've got these complementary tools, and the key thing here is that they all work with each other with very few changes. Something that just was released was this eventing framework, Kada, up in the top there from Azure. And again, just like Knative has an eventing system, Kada has one, OpenFaaS has one. And so I want us to think about this as a kind of big tent thinking, how we can interop together. And this convergence that we all thought was going to be the function signature in the serverless working group originally, perhaps isn't. Perhaps it's a Docker image, and that might be enough. Now, you can run these on two different platforms, right? Kubernetes and OpenShift, which is largely a distribution of Kubernetes. But you can also run them on hosted platforms. Cloud Run, OpenFaaS Cloud, Azure Functions. Right, and so this is what the talk is about today, is a serverless 2.0 landscape, and I hope it resonates with you. So let's get into some of my highlights for 2019. We relaunched the OpenFaaS website, and it is absolutely beautiful. There's no way I could have made it look like that. I needed a lot of help. Go and check it out. We have a new template store, which allows people to discover, remember that top part of the diagram, all of the templates for OpenFaaS. And we've had many contributions, even from Knative developers at Red Hat, for Quarkus, for Vertex, Java itself, and even things like Rust. So if there's a language you don't see, you can just create a template, put it in our manifest, and then it's available on our CLI immediately. We also built out something called the community cluster, again, because we want to get feedback just like you guys do. And what that means is that people can push code into GitHub, and they get a URL within a couple of seconds. That URL has TLS, and they can deploy whatever they want there. A guy in India called Rajat from Proofpoint deployed Good First Issue Bot, which is being used by the Tecton project, by Google, Go, GitHub, and some other projects like OpenFaaS. What it does is when it receives a webhook of an event being tagged, an issue being tagged with a good first issue, it will tweet it, right, to attract more developers. So I really liked that innovation. Now you can also bootstrap the entire system self-hosted in 100 seconds. Now OpenFaaS, as I said, remember in the beginning, was just me trying to hack on Alexa. Well, now it's way bigger than that. The Slack group is growing, and 400 of those people joined in the last couple of months. Many of them on the survey when they join are using this at work already. Quite a few stars, but something I'm very proud of is 200 plus contributors. People that have had a PR merged, that decided they want to be a part of something bigger and they want to contribute. So some of our traction that I like even more is this idea that these are the events we've discovered year by year. So people, when they go and do an event and talk about OpenFaaS, maybe at a Docker birthday, will submit their file to the community file, and this is what it looks like. Projected on 2019, we're looking at almost 300 blogs. So it shows a lot of developer love, and something is right there that's really gelling with them, and I want to see more of that. Now, we also go back to grassroots. In Bangalore, we've had a first meetup group. Currently it has 500 people there, and they just decided one day they were going to create it, and it's been very, very popular. So thank you to Vivek. Team Serverless is what we call our community. These are all the people that have contributed, and rather than rolling out a mosaic for a keynote, this is actually a core part of the homepage, and when you land there, a random selection of the 200 contributors is shown front and center. It's very important to the project. It wouldn't be where it is today without them. Thank you. Now, we often have webinars, Zoom calls, and just connect with each other, and the most popular was how to contribute to OpenFaaS. We've run it twice, and it's surprising, right? How to contribute. It's very popular for us. So for us, it's about community and investing in people. In particular, there's 13 really loyal developers that have come alongside me, and at least two of those are here today. Ed and John, thank you so much for coming out here. These are the core contributors, and they help with the leadership and running the project. And then there's a bunch of other guys who are there, spending their evenings and weekends like I was, hacking on the code, answering questions. Now, an open source project is great, stars are great, but we want to see some real usage in production. The Press Association is one of the companies that got in touch with me in the UK just before I came out, and they said we've rewritten all of our deployment pipeline from old monolithic tooling to using OpenFaaS functions. We've saved a lot of time. British Telecom are here with me today, well, tomorrow rather, and what Yoast has been able to do is to take the research algorithms they used to build. It took them around 3 years to get from the idea in a scientist's head to something in front of a customer. It's now 3 months, which is really a big improvement. For them, they like the fact that they've got endpoints very easily, metrics built in, and scaling out of the box. So they've really reduced their time to market there. If you want to see their talk, our talk, it's on Wednesday. Now, for a lot of other people here, one thing they really like is the fact that there's that Docker image, right? And I like that Knative is also going down that line. If you've got a Docker image, you've got so much more versatility and things that you can do with it. Whitel are a GCP customer, and one of the things they wanted to do was to take a long-running customer transaction and make it faster. The way they did that is by splitting out parts of it and running them asynchronously through OpenFaaS. That means they can get a better customer experience when they purchase, but also they don't have to scale the entire application. They just scale at a kind of micro level. Vision Banco joined me when we had last KubeCon in December, and they talked about how they were able to take these flaky Fuse ESB microservices and monoliths and skip straight to functions with Node.js, enjoy very high uptime. Right? A lot of these companies are early adopters, but now we're starting to see banks and other companies come alongside and figure out how to use serverless. And I'll tell you about the architecture because you may be wondering, particularly if you have used some of the other projects. We've got a command line, UI, and REST available. If we walk through on the top, the API gateway sits there and exposes its REST API. We may deploy a function. Would they have CRUD or invoke to a provider, and then we've got a function on the other side. Now, the gateway doesn't know what the function is. It could be a pod, it could be a Lambda, it could be a container in Docker Swarm. And that's a key part of the project, is that that can be swapped out. And I recently heard about a streaming company with a backend called Titus that was able to get something up and running in a POC very quickly just by taking that entire ecosystem and swapping the provider. Right. Our scaling at the moment is done through Prometheus metrics. We've got rate, error, and duration, and that can then be used to scale up and down. You can also build your own auto-scaling, and I believe Darren Shepherd from Rancher is doing that. He's taken part of the Knative code. He's been able to use it with OpenFaaS and the RESTful API to implement the same scaling. NAT streaming provides us some queuing support, but other event sources are available. And we also have ARM support. This isn't brand new. This is something that's been there from day one, and that's also data center grade if you need it. I was really excited to see Docker and Red Hat getting behind ARM in a big way, and I think that's going to be really important, and I'd like to see that in all of our projects as we move forward, this full support for multi-arc. So events. Many people that have heard of OpenFaaS think that it's just about HTTP, and that does play a role here. But if you want to use any of these connectors or your custom one, we've got a Go SDK. You can write your own very quickly. What you do is you take your function and you put an annotation on it with the name of the topic or topics it cares about. We then create a connector, and the connector will connect to your broker. When it receives a message on topic payment received, it will then look up the map and it will know what to invoke. Does that make sense? Yeah? So we'll get on to a demo now. We're going to look at the ecosystem of OpenFaaS and how that can interop with other projects. First of all, we have the function store, which is a manifest and a way that developers can get their code and share it with other people for reuse. Some cool stuff in there, like the colorization function you might have seen at KubeCon a couple of years ago. We have a templating system where that Java, Quarkus, Vertex templates can be brought together. And then functions and microservices are both fair game. What I'll do first of all is connect to a bare metal machine I have on Packet that's running Kubernetes. And we just have a single node here. Right? And what I want to do is show you the function store, FaaS CLI store list, and we see a bunch of functions that are available. You can swap out the manifest if you want to. Then I'll show you the UI for OpenFaaS. And from here we have a view that's a bit like Postman. You'll see your request and response. You can invoke here and test stuff out. We also have the function store in a visual way. So I can just deploy one of these functions right now and would have it in the cluster. And let's go back to a terminal. So if we do a list and decide we want to deploy something like have I been pwned. I don't know if you know what that is, but basically Troy Hunt has collected all of these breaches, and they have passwords and hashes, and you can submit your own password and see if it's been used in a breach, and then if you want, change it. So I thought we would have a quick look at this. And we'll put something like KubeCon into it, and 8 people have had that in a breach. We'll try something like Knative, perhaps not so well known, OpenFaaS equally not. So we've got that function up and running within a few seconds from a common store. Now, we also have the ability in OpenFaaS to take, let's get into the Knative one, to take any binary and make it a function, something that I'm not sure if you guys have had much of a look at yet, but if we look at this dig version, I have a kind of sidecar that's put in a container that, if you like, is like the old-fashioned CGI bin execution model. We just say what process we want to run. I want to run dig, look up a domain. Me and Ed were doing this in the airport. We had a DNS problem. It's always DNS. So I'm going to invoke that on OpenFaaS, and I'm feeling quite vulnerable here because this is a real cold start. That took 3 seconds over the internet, and I've done a dig. I'm now going to do it on Knative, and this has been the same function, and if we run that, takes about twice as long. There's various reasons for that, but it's exactly the same code deployed on Knative, and then obviously the second time is much faster. The way we've done that is by extending our CLI to add this generate command. So if we're in a folder where we have some code, let's do a new one. And we go store, template store list. See all those languages I talked about? Let's pick something fashionable, Rust. Now I can go template store pull, Rust, get that down, do a new function with it, language Rust, Knative. And in a short period of time, I can now do an up on that. That will build an image, push it, and deploy it. But this is the bit that is different now, is I can do generate. And that's giving me an OpenFaaS CRD. We want a Knative one. So I just type API, and I've got the string here, I believe. Let me see what it is. Serving, okay. And now we've got a serving definition, and I can literally just apply that with kubectl, and that will go straight into the cluster, right? It'll be deployed as a serving definition. So I'm going to do one from the store instead. So store, deploy, figlet. So generate from store figlet, API, serving. There's our CRD, kubectl, apply. We already had that one. We can do a different one, node info. And then if we get our events, we'll see that Knative has gone off. We had that serving definition. It's creating the pod. It takes a little while to pull the image down. We've got a full endpoint, right? So we use the entire OpenFaaS build tooling to work with Knative, which I think is pretty cool. We've got that out of the box. And I don't know if you guys did that on purpose to interop or not, but I really like the fact that we can do that. Now, Kelsey Hightower, he said that, if you walk down a Home Depot or a B&Q if you're in England, you see lots of tools. Sometimes are very similar, but you pick the right tool for the job. Multiple tools can coexist, and they should do. We have Linkerd and Istio. We've got OpenShift and Kubernetes, and many other like that. Now, serverless is no different. Some of the things about OpenFaaS is that we've really focused on developers first, making sure that CLI experience, the ecosystem is there, that it's very easy from the top to the bottom. You can also use OpenFaaS as primitives if you want, as building blocks. We try and give you the full experience. It's operationally simple, which means we're trying to give you something that's lightweight for your cluster, that's not packaging a lot of additional components like perhaps ELK or HA configurations of Kafka. And it's also community-centric, as you saw. Now, I told you a bit about OpenFaaS Cloud. Now, OpenFaaS Cloud was something that I created to get from source to URLs very quickly, because not everybody needs to know the ins and outs of Kubernetes to get an endpoint. Sometimes you've just got a bit of code, like you're a Lambda user, and you want an endpoint that's production ready. So I created this based upon user feedback, and often would find that there'd be end users that wanted an endpoint. The team lead knew Kubernetes very well, but the rest of his team were regular developers who didn't care. So this is something that they can install, and their whole team can then get access to that. Or, as in a community cluster, we self-host it for the community. It's a managed experience. Everything is automated, and there's very little for you to think about. It's multi-user, and then you get your own dashboard with OAuth 2. You can log in with GitHub and GitLab. Perhaps we'll add other providers in the future. And then you're able to set policy and quotas for the whole cluster, so we can actually see what it's like and what people need out of a multi-tenant system. Now, there's still a lot of work to be done here. I know there's various working groups and other things that we can tap into here. If you've got ideas, if you want to try it, it's all open source, and you can set it up in about 100 seconds. The way it works, as you might expect from a CI/CD pipeline, is it all starts with a git commit. You do a push. Now, that push goes to your source control system, github.com or GitLab self-hosted. The webhook goes to some receiver code, and that receiver code has one hook for the entire Git connection. Right? There's not one per repo, one per project. It's just completely automated. We'll then build your image after checking it out and cloning it, push it into a registry, and then deploy it to OpenFaaS on the gateway. And then you've got your function. So whatever 3 functions you had in Git are now deployed in the cluster in completely automated fashion. And as we saw, we can also deploy to Knative. So there is the opportunity to potentially extend this and make it even bigger. I'll just let someone take their photo. Thank you. So this is what it looks like. And I don't know if you can see it from the back, but there's 3 functions there, which are part of a demo I'll show you later. And each of them has got a tick. The tick means that it built OK and the unit test passed, and it got deployed. And then there's one for the overall stack. Any secrets that you've got there that you've defined in your repo will also get imported, and secrets are really important when you start doing this sort of thing. You'll then get a dashboard that looks like this. And we've got all of our statistics there, the names of the endpoints. We can get how many replicas there are, and you can see some of them are scaled to 0. And then you dig into it a little bit more. We've got metrics that are brought out of Prometheus, and we're working right now on surfacing the logs in the UI as well, as you're doing your invocations, right? Because it is pretty hard to debug something when you don't have any logs. But there's a nice button here to run it locally, and if you click that, it will bring it all down to your laptop, and you can debug it and figure out what's going on with it. So let's have a look at this demo, and I'm not sure how we're doing for time. I think we could probably try this. I put together a single-page app. Why? Because I want to show you that you can do real programs with this. You can build applications for line of business and that are customer-facing. Right? It's not just about inputs and outputs and Dockerizing dig. So this leaderboard is collecting webhooks, and it's collecting issue comments and issues opened. If you work, some of you here may work on open source commercially as part of your day job. You probably have some kind of tracking like this in your open source program office. Maybe you know about it, maybe you don't. Now, if you want to have a go at it, please take the URL. I don't mind if in the interest of time we don't. But this is a URL. I'll keep it up. Sorry. And we could just try it out. We only need a couple of people. So you click on the issue, and just like we saw, we imagine that we're tracking some metrics on our engagement on an open source project. Thank you, Ed. And we're getting the comments coming up live. But the interesting bit is what's happening behind the scenes, which is this entire application built with serverless. We've got a Vue.js microservice that's serving static HTML that's been built for a proper build toolchain. And the user's coming along and accessing it. He's got full TLS there. That page is then doing a request back to the server through Ajax saying, I want the data from the Go leaderboard, written in Golang, returns JSON. That's rendered on the page for us nicely, and it's just doing a select from an RDS, a remote database. Every time you, as a contributor, interacted with GitHub, we then had a pub-sub relationship with GitHub, and they sent us a webhook. We verified it for security reasons, and then inserted into the table. Right? And so I just wanted to show you a full example of a serverless application. And maybe as you're seeing this, you could think about how this might apply to your work as well. Now, Joe Bader had a little look at OpenFaaS in the very early days, and again, as being quite vulnerable here, he managed to open up to the whole internet with a very tiny URL so everybody could get to it, and said, please be nice. And within a few minutes, somebody deployed a Bitcoin miner, because you can run any Docker image. And it used up all of his T2 credits on his instances and destroyed his cluster. And that's why we need authentication by default, which is now a core part of the platform. We've got non-root everywhere, which includes not just what we deploy, but what you deploy. And that means that you can't get malicious, well, in theory, right? It means you can't get malicious code into your function code or your base layers or your runtime. That's the idea. You can still write in a temporary directory if you need to. Within OpenFaaS Cloud, that offered us another opportunity to do more security and explore different use cases without changing the core platform. And that's meant being able to use Bitnami's sealed secrets, popularized through Weaveworks. And so that GitHub example that I showed you, if we open the code for that, what we'll see is there's some encrypted secrets that were just put straight in the repo. And so if you literally wanted to try this example, all you'd do is fork the repo, install the webhook, and then reseal the secrets with your own values. It's really that simple. And then we have the OAuth 2, which was actually really interesting to work on, and would like to expand on that for other providers. It means you get two-factor auth. So in terms of performance, one of the things exploring this with end users, particularly BT, was they were hammering it in ways that we hadn't expected them to do, where they were creating connections and deleting them halfway through the request. And I said, we think there's a problem. We've switched to using Ingress because we thought OpenFaaS wasn't designed for this. It's like, no, please, no. So we looked at it, and over a couple of weeks, figured out that there was a problem with the way Go client was using DNS. We got it fixed for them and rolled that out. And then we've had new users come along board and say, thank you for that patch. That was great. We really got a performance boost out of that. And this is something that you get from working in an open source project. We also have templates that make use of HTTP servers like Knative does, and means you can get a very high throughput, effectively the same as if you were just running that web application on Kubernetes bare. When it comes to health checks, we try to build in as much abstraction as we can so that as a developer, you're not having to think about that up front. Right? It's a simple surface area. We were using exec health checks, which will run a liveness readiness probe as a binary on the node. And it turns out that can be CPU intensive. So instead, we started to look at HTTP probes, and they seem to work a lot better, and they're giving us more throughput. We also have the ability to swap out OpenFaaS, own auto-scaling with anything else, including HPA, and we've got custom metrics to support that now. Now, some people have been talking about zero scale, and this is how we've done it. We've got that REST API, and one of the endpoints there is to scale to n, right? And it could be 0. When you invoke a function, the traffic comes in, and the gateway will say, is there a ready replica available for this function? Is that pod available? If there is, we'll pass the traffic through, all good. If not, we'll ask the API to scale to n, and as soon as there's one ready replica, we'll let the traffic out again. Now, I know there's different ways of doing this, but this worked for us, and it seemed to be a pretty simple approach. We'll then scrape metrics through Prometheus, and that means that an idler component we've written, and you can also write your own, will then call that API and say scale to 0 if it's met certain criteria, i.e., is the pod idle for 10 minutes, right? I think you guys are using 2 minutes at the moment, as I observed. So that's how we're doing scale to 0. Now, in terms of the top blog posts this year, serverless single-page app was really something that was important, and I think we should all try and do a bit more of that whole application kind of stuff. How to write a serverless application in Go, using functions or microservices. And then in that blog post, you'll see that if you just route it as a regular Kubernetes service, you have a big Docker file to maintain for every endpoint, right? And you have all of this duplication, And now when you have 500 of those, you've got a real pain in the neck, right? Now, what if you also have a deployment and service YAML and ingress for them, plus a JetStack certificate? Well, the kind of platforms we're talking about today automate all of that, and you can go down to as little as 4 to 8 lines of code for every service. GitLab with OpenFaaS Cloud means that you can get completely on-premise with all of this, even work in an air-gapped environment. That was also pretty popular, and you can check out the blog if you want to see more. So as we start to wrap up the talk and come to the end, we want to tell you something that we're looking for the future. OpenFaaS right now is serverless functions made simple, right? We want it to be easy to use and install within a minute. For that reason, we've got a core namespace for all the OpenFaaS components and an OpenFaaS FN namespace for the functions. If you want to have different stages or different environments in the same cluster, you can install multiple times. What we're now looking at doing is being able to have one installation and multiple namespaces, and then effectively you've got multiple tenants there. Does that make sense? Now, within that, trying to see whether it's actually valid and acceptable for the enterprise to have a cluster role that's basically root on the entire cluster. Because what we have right now is least privilege to one namespace. Something maybe we can chat about later. OAuth 2 for our REST API is something that several people have asked for in the enterprise, and I think it could be really useful for things like our event connector pattern, so that you can have least privilege. All I need is list functions and invoke. So we're looking into that. Lucas, that's joining us tomorrow, he has a talk on how to contribute to open source. He's working on logs for our CLI. Right now, we just use kubectl. People are pretty much all right with that. We're just doing what we can. And then taints and tolerations. Again, this is like an open discussion here. How do we take something as complex as a affinity or anti-affinity rule and expose that to the user in a way that makes sense? Right? Because if you dig into it, it's a very complex structure in Kubernetes. And a lot of the wins we've had with OpenFaaS is taking the complex and making it more accessible. But I don't know the answer to this, and I'd love to chat more about it with you guys. So summing up, OpenFaaS is lightweight, it's easy to use, and it's simple to operate. It's serverless on Kubernetes. It's been trusted in production by over 40 companies on a homepage. It runs on OpenShift, ARM. It will work with Linkerd, with Istio, and even, as we've seen today, with Knative. And it's been built by a healthy, organic community of volunteers, right? This has not been corporately funded. This has been built by people in their own time, and it's been treated seriously and used in production. So I think we're really punching above our weight a little bit here, and feel really blessed to be here with you guys and to share in this event. So thank you so much. Now you can get connected with us because we're all about community. You want to meet this week? There's talks on Wednesday and Thursday. And if you see any of us in the hall, just grab us. We've also got the BOF in the afternoon for OpenFaaS. You can come with questions. And take a photo of that. If you like, you can join Slack. It's the easiest way to get connected. Great. Thanks for being such a great audience.